It is easy to imagine how in a microservice architecture, a web application can have many layers of dependencies. For instance, on the left, we can see that a simple voting web app relies on a Python-based UI to capture votes, a Redis queue to collect the votes, a .NET worker to consume and store the votes, a Postgres database backed by a Docker volume to prevent loss of data, and finally a Node.js-based UI to display the results in real time. Such a scenario is very common. Docker allows us to containerize these individual service components. With traditional Docker, running these multi-container applications had an overhead of managing the linking between these individual components, the order in which they were created, and which network and ports they were sharing in order to communicate. And if there was an issue in one container, all the containers linked to it must be taken down and then restarted. Thus, it took multiple commands to achieve what was needed and was more error-prone. However, with Docker Compose command, we can use a single composition file to easily configure all the services required by the application. With a single command, we can create, start, and run these containers. Similarly, without Compose, one must use Docker PS to see all the containers that are running and remove them either one at a time or combine multiple Docker commands to achieve it. Stopping and removing all these containers has also been made easy with Docker Compose. Today, we will be looking at an example using Docker Compose. In this demo, we will be using a simple Node.js-based app called Let's Chat. It connects to a MongoDB instance to store information from the application. This is the Docker Compose.yml file where we configure the services required to run the application. The services section is required. Individual components will be defined and added in this section. In here, we just have two. One is called app, which is the Node.js chat app, and the other is called Mongo for the MongoDB instance. The link keyword allows us to establish communication between two services, while the ports allow us to define a communication channel between two or multiple services. Now, when we type Docker Compose up after build, the daemon will be downloading the images from Docker Hub for both the app and the MongoDB. It will build containers for them and also start both of them. The first time it pulls these images, it'll take a while. For later uses, if they are not removed, it'll load much faster. Now, on the browser, when we navigate to localhost on port 8080, the app is loaded. In order to test if the connection between the app and the database has been made, we try to register and create an account. It displays a success message. And when we try to log in with the same credentials, it is also successful. Thus, the communication between the app and the database seem to be working. Going back to the terminal, we can see the list of all containers by typing in Docker Compose PS. Currently, we have 2 containers. And if we type in Docker Compose logs, we can see the output from all the containers in one place. This comes in handy when trying to debug. We can stop all the services related to an application with a single command, which is Docker Compose stop, and remove all the stopped containers with Docker Compose rm.